Greetings, beautiful people. Today let's dive into circle theorems, one of the most challenging areas that students struggle with. We are here to break it down to make it understandable. Now let's start. We have angle at the center theorem, and it states that in a circle, the angle created at the center by two radii is twice the angle at the circumference by the same chord. Let me break it down. So we are saying that the object has to be a circle, and then another angle is formed at the center. How is this angle formed? It's formed by using two radii. That angle that is formed at the center is twice another angle that is created at the circumference. The key condition is that these two angles must be created from the same chord. Let's start by drawing our circle. So we have a circle with center A. Now the center is one of the most important parts of a circle. First, we need to create the angle at the center. The angle must be created by two radii. Now radii is any line that is drawn from the center to any point on the circumference. So let's draw a line that is the radius on the circumference, and then another line from the same point that is the center. We have two radii. An angle has been formed, that is angle DAC. Now what is a chord? A chord is any line that touches exactly 2 points on the circumference. Touches how many points? 2 points on the circumference. So it means that we can connect point D and C to form a chord. Point D and C. So line CD or line DC can be described as a chord. Now we are saying that the angle that we are going to create at the circumference must be created from the same chord. That is, it has to come from line DC. So D to any point of the circumference, and then C to connect the angle. Now let's draw another one. So D to any point on the circumference, and then C to connect that. So we have created two angles. The next thing I want us to do is that we are saying that the angle at the center must be twice the angle at the circumference. So let's measure the angle at the center. When we are done, we are going to measure the angle at the circumference. The angle at the center is angle DAC. Let's measure that angle DAC. That is 90 degrees. Then let's measure the one at the center. So if the angle at the center is twice the angle at the circumference, if you are having angle DAC to be 90 degrees, what will be angle DEC? Let's measure that. DEC, that is 45 degrees. So we realize that the angle at the center is twice. So if I multiply 45 times 2, that is twice this, it will give us 90 degrees. You realize that we have also created another angle from the same chord. Guess what the angle is going to be? Angle DFC. What is that angle going to be? Pause a second and then guess. Alright, now let's measure to C to verify your answer. So angle DFC is also 45 degrees. Why is this giving us the same value? The key indicator is that they are all coming from the same chord or by the same arc. Do you get it? So the angle at the center is twice the angle at the circumference. Alright, so let's see what can happen if we decide to change the size of the angle at the center. What is the consequence? What is going to happen to the angles at the circumference? So let's start moving the points around to extend the angle size. So let's assume that we are changing the angle size. It changes automatically. The angles at the circumference will also change, and at any point in time it is twice that angle. So if I have 45 degrees at the center, the angles at the circumference will be 22.5. That is exactly twice will give us the center angle. So if I multiply 22.5 degrees times 2, it is going to give us 45 degrees. What about if we decide to move the angles at the circumference? Is that going to change? Alright, so let's move. So if I move this angle, what do you see? Is it changing? Is it changing? It is fixed, right? It is the same. Why is this so? This is so because the angle at the circumference is dependent on the angle at the center. So once the center angle is the same, it doesn't matter where the angle is formed at the circumference, it will always give us the same thing. So you realize that moving the angles around at the circumference doesn't have any effect. It's almost the same. So a key reminder, make sure that the angle at the center and the angle at the circumference are all coming from the same arc, and they are all facing the same direction. So you realize that this is facing the same direction, the angle at the center is facing this direction, this is also facing this direction, they are all facing the same arc. It means that when they don't face the same arc, it will not work. Example, if I move it in the opposite direction, do you see any changes? Okay, so do you see any so you realize that now it is not the same, because this angle, the angle at this center is facing this direction, the angle at this center is facing this direction, and then this is also facing this direction, so it will not work. It has to face the same direction. And then also you realize that they are all being created by the same arc. Very good. But this is in this direction and this is in the opposite direction. It will not work. It has to face the same arc. It has to be in the same direction. All right, so let's move it. Once it faces the same direction, realize that now the same direction, it's the same measure. 67.5. This is also 67.5. Once I change the center, it will also change automatically. So 45 change to 22.5, and then let's also, so anytime the one at the center changes, it affects the angles at the circumference. You see that? It's always like that. All right, thank you for joining me, and then see you in the next video.